to this Elsewhere webinar, Building the Agentic Enterprise, AI Agents and Multi-Agent Systems. I'm your host, Elliot Levy. I run the content here at Elsewhere, and I'm joined by Leon and Fahid, who will be talking you through our findings and work today. Just a quick one about questions. There will be questions at the end, so do stick around. But without further ado, over to you guys.
Good morning, everyone. So thank you for joining. Let's see if my slides work. They do. Excellent. So my name is Leon. I'm the co-founder of Elsewhere and the Chief Product and Strategy Officer. I'm ex-software engineer, and my thinking gets published, my ramblings get published sometimes on Sifted, VentureBeat, CTAM. I'm going to give you a brief intro about Elsewhere. So for those that don't know us, Elsewhere is a digital product consultancy. We accelerate innovation to solve your business critical problems. We're consultants that can implement end-to-end. We vertically integrated this consultancy model with strategy, design, and engineering on equal footing. So our services range from digital strategy, product design and build, cloud platforms, and AI. In the last year, we've been doing work with generative AI for our clients, and our belief in this technology is captured in here. We basically think that generative AI and intelligence itself is a commodity. The key differentiator is about shaping that commodity to solve the right problems in the right way. And today we can help our clients with these solutions. So RAG, if you heard of that, it's a retrieval augmented generation. So it's a way to blend proprietary data with AI to reduce hallucinations and deliver accurate information. Copilots, we create AI tools that embed seamlessly into workflows and understand the task at hand. And AI agents, so streamline operations with AI agents, freeing you to focus on strategic tasks that drive value. And this is really what we're here to talk to you today, because we think 2025 is going to be a huge year for agents. Without further ado, I'll pass on to Wahid.
Hello, everyone. I'm Wahid, Senior Principal for Engineering at Elsewhere. I have 20 years experience in software engineering, and 10 years of it I've been working with Elsewhere. I lead the generative AI initiative at Elsewhere, and my focus is embedding cutting-edge AI technologies into real-world business problems. So let's talk about agents, and we can't talk about agents without mentioning the foundation models. Next, please. When ChatGPT came out, many of us were blown away by its capability to generate understandable output in plain English. What was crazy was that the answers also made total sense because they relied on its pre-training knowledge. What blew my mind personally was thinking about all the possibilities and opportunities that these models could bring to us through a single API, all the different types of apps we could build on top of it. This got even better because soon we realized that just like humans, generative AI models can be trained to use tools to let them access real-time information or suggest a real-world action. This means that many applications previously thought impossible are now possible. Workflows that used to be unautomatable could be automated. This makes AI useful for increasingly more and more aspects of life, vastly widening both the user base and the demand for new AI applications. In the last couple of years, building applications on top of LLMs has evolved into two main patterns. Next, please. RAG applications and agentic applications. Consider RAG as a system that knows your corporate data, and you can interrogate against a company knowledge base that it's not available to the public. This has already proven to be very impactful, and we already have many systems in production with our clients that use RAG principles. Agentic systems, however, use LLM reasoning capability to do tasks. You can instantly see that this pattern comes across much more promising than RAG. This is because it's directly linked to automation and can impact a much wider aspect of business workflows within an enterprise. These new capabilities of foundation models, makes it finally possible to develop autonomous, intelligent agents to act as our assistants, co-workers, and coaches. They can help us to create a website, gather sales data, plan a trip, do market research, and the possibilities seem endless, which leads to a massive potential economic value. But before we jump fully in, let's just first define the AI agents. What are generative AI agents? So, agent is an autonomous entity, operates without human intervention, interacts with its environment, and gets feedback and uses those feedback in order to make a decision to achieve a goal. So in a nutshell, agents can use tools to access real-time information and interact with their environment. Agents are autonomous and can act independently, and agents can also be proactive in their approach to reach goals. That means that even in the absence of explicit instructions from us, an agent can reason about what should be done next to achieve its goals and just do it. So let me give you an example. Next, please. Imagine we ask ChatGPT to write a social media post. Its output can be too long for a post or could miss hashtags. So we have to give a feedback to ChatGPT and say, okay, can you shorten the post or can you add the hashtags? Bear in mind that, and ChatGPT comes with a better post that follows with the guidelines that we specified. Bear in mind that the ChatGPT didn't come to conclusion by itself. I still had to tell the chatbot that what it needs to change. But an AI agents are autonomous and should work without any human intervention. They use LLM to ask and answer their own questions, which serves as a feedback to further improve their output. In the example, ChatGPT did not arrive the final answer autonomously. It also didn't have the tools available to it to post the content straight into social media after my approval. I still have to do it myself. Multi-agent system can think about their answer, judge the quality of their answers, and use the tools available to them to push the process further until they reach that final goal. This means that we don't have to sit and constantly interact with the system. Next slide, please. In order for agent system to be impactful in the enterprise, there are some structures and ecosystem around them. Let me discuss those. Next, please. In multi-agent AI system, these concepts represent different aspects of how agents operate, coordinate, and interact with their environment, tools, and even each other. We have identity, planning, scoping, external tools, memory, and collaboration. Let's start with identity. One of the most common type of real-world instructions for LLM is role-playing, asking the model to assume a fictional character or a persona. You can simply ask LLM to explain a complex concept to you like a secondary teacher. And this dramatically will change the style of the output of the model. Role-playing or giving your agent a persona is very powerful and can serve many purposes. It's a technique to improve the quality of the model output. A persona can help the model to understand perspectives it's supposed to use to generate responses. It makes it easier to give an agent a specialization and role assignment. Different agents can take on a specialized role with distinct behaviors. For example, a Java developer, a copywriter, a project manager with knowledge with Jira. When you design a multi-agent system, given identities allows the system to distribute tasks effectively and prevent redundant processing. Example would be in a code generation system. One agent can focus on writing the code, while the other one is a code reviewer and know the best practices and reviews the code. There are also some system design aspects that you have to include in this. Identity allows agents to refer to each other, delegate tasks, and build workflows. Without identities, interactions become chaotic and with no clear ownership of responsibilities. If agents have distinct identities, a plan failure can be traced back to that specific agent rather than a system as a whole. I mentioned plan, so let's talk about planning. Planning is another key aspect of agentic system design. Many tasks are complex. They cannot be done in one single step. These complex tasks require planning. The output of the planning process is a plan, which is a roadmap outlining the steps needed to accomplish a task. Effective planning typically requires the model to understand the task, consider different options to achieve these tasks, and choose the most promising one. Remember, you can't sometimes identify all the subtasks ahead of time. This is because unpredictable circumstances. You have to let the agent decide dynamically based on the information available to it. Bear in mind that with these systems, we are automating workflows that used to be unautomatable. One aspect that traditional software engineering couldn't automate some workflows was that they were unpredictable at times and human intervention was necessary. But now, with current reasoning capability of LLMs, they are good enough to automate the process entirely. Let me give you an example. For instance, an agent that reads internal documents in a company to answer a user question. An agent may think that the documentation provided by the organization is not good enough to make a solid answer or support the answer. So it may replan and use the internet to gather some more evidence to support the answer that was provided in the document in the first place. So it didn't ask us, it just came with that conclusion autonomously based on the initial findings. So let me touch quickly on the human in the loop as well. This is still a very guardrail process. Agents should know what tools it has in its disposal and what are the constraints. You can always define the limit on which the agent has to act autonomously. For example, tasks in which an agent has trouble generating the whole plan, a human expert can still provide a high-level plan of the agent that it can expand upon. If a plan involves risky operations, such as updating a database or merging a code, the system can ask explicitly for a human approval before executing or let the human execute this operation within the agent's scope. Which brings us to scoping. Don't let tasks become too big. Research has shown that providing LLM with excessive information and context actually decreases the performance and increases hallucination. An agent often needs to perform multiple steps to accomplish a task, and overall, accuracy decreases as the number of steps increase. If the model accuracy is, let's say 95% per step, over 10 steps, the accuracy will drop by 60%. And over 100 steps, the accuracy will be only 0.6. There is also a research published by Databricks. That's the picture from that research. You can see in the screenshot that as you maximize the usage of context window, LLM performance drop against certain benchmarks. It's up to us to keep the scope narrow. We give agents identity and task context to do the job, but not too much context that it loses sight of the task and the goal. When designing agents, it's important that each agent has one and only one single goal. So let's say in a code generation multi-agent system that I mentioned before, there will be one agent to analyze the requirement and user stories and translate them to solid features. One agent decides on the architecture and best practices. One agent writes the code and fills the existing architecture with components. And then another agent can act as a QA. Remember, the same concept applies to the tools as well. Overwhelming the model with numerous number of tools can be counterproductive. You just have to give them enough tools that they need in order to do the job, which leads us to the external tools. Look at the screenshot here. This is from LangChain website. It's one of many open source frameworks in order to build multi-agent systems. There are hundreds of out-of-the-box tools available to agents just within the LangChain. This could be a calculator, finance tool, Salesforce integrations, and so on. An agent doesn't need to access external tools to be an agent. However, without external tools, the agent capabilities will be limited. By itself, a model can typically perform some actions. For instance, multimodal models can generate images, and you don't need to rely on a tool. But external tools make an agent vastly more capable. They're absolutely important and give agents superpower by calling external APIs, collecting data, searching the internet, which means communicating with the outside world. Tool calling in a agentic system has already shifting the software engineering ecosystem. Agent calls API in a much more frequent way than traditional system. Let me show you something. Next. So this is a tracing analytics from LangChain that use for agentic system in production. So this shows the number of API calls that LLMs make autonomously. You can see the huge increase in the 2024. That shows that people or companies are more and more using multi-agent systems in production. And you can see as a result, the increase in number of the APIs that LLM make to external tools. So it's important to know that when we talk about multi-agent system, we're not talking about the vision anymore. You can see the data and even witness the shift in the market. Speaking of market, let me show you another image. This is a screenshot from a Stack One website. A Stack One is a company that provides generic APIs that has a lot of other product APIs built in so that developers don't have to write different integration for different APIs. So it has a Slack, Salesforce, all of that built in. So you can see how a Stack One is positioning itself as a suitable API client for agents, because they've seen the shift in the market and they've seen that the developers are not going to be their only client anymore. And a lot of API calls in the future are going to be made autonomously by LLM agents. Let's go next. Memory plays a big role as well. Overall, we have two types of memory, a short-term and a long-term. The short-term runs each time agent runs a task, remembering what the task is all about and what was the main goal. Long-term, however, relies on the previous runs of that task. What were the past actions and processes, and what we can learn from those through the process called reflection. Imagine if two agents are collaborating and one agent is checking the work of the other. It evaluates the output and provides feedback to the first agent. These feedbacks can pile up and be stored for the agent to use it as reflection. So next time that agent wants to run the task, look up to all those feedbacks and see what kind of pattern can it find to do the job better. This is very valuable. It allows them to get better and better over time. So before each task, the agents run a reflection on the previous task and see what he can learn from it. Even the best plans need to be constantly evaluated and adjusted to maximize their chance of success. While reflection isn't really necessary for an agent to operate, it's necessary for an agent to succeed. Next, please. I did mention about agents talking to each other. This is actually quite a solid pattern. We believe most of the workflows in the enterprise can't be automated with just one agent. Which gets us to the subject of multi-agent systems. You see, with LLMs, apart from need for giving them identity, the back and forth conversation always works better. It makes agents work together and collaborate. You can implement a reflection in a multi-agent setting. One agent plans and takes action, and another agent evaluates the outcome after each step. If the agent's response failed to accomplish a task, you can prompt the agent to reflect on why it failed and how to improve. Based on this suggestion, the agent generates a new plan, and this allows agents to learn from their mistakes. There are many patterns for multi-agent systems. Some major ones are sequential, hierarchy, or competitive. Sequential is a chain of agents passing the output to another agent as an input, down the line from one agent to another. But the problem is that the context gets lost down the way. We also have hierarchy, where there is one agent acting as a manager, that always knows the context and reviews other agents and delegates them tasks. And we also have competitive, where group of agents work in parallel and give the outputs to the manager, and the manager agents decide which output was the best and picks that one. Let me give you an example on a multi-agent system that posts social media posts. You can have one agent as a researcher. It can check the social media and check for the latest trends in your industry. You have another agent that is a copywriter. It would prepare a draft. You have an agent, he's a manager, as an editorial, and checks that draft. And if he's not happy, gives a feedback to improve that draft. You can have the agent that actually write the content, and you can have an agent that creates an image for that social media post. Another agent has the API tools available to it. So when editorial is happy with the final post, it publishes it through the social media via API. So you also can all of this in a competitive layout where they work in parallel and provide the editorial with many posts to choose from, and the editorial picks the best one and posts it online. Well, thanks a lot for staying through this presentation. I pass it back to Leon.
Thank you, Wahid. That was super cool. Very interesting. Want to talk a bit about the opportunity we see ahead. So first of all, I want to circle back to where we started and go over our definition for a generative AI agent, just once again to remind everybody. A generative AI agent can be defined as an application that attempts to achieve a goal by observing the world and acting upon it, using the tools that it has at its disposal. Agents are autonomous and can act independently. Agents can also be proactive in their approach to reach goals. And generative AI models can be trained to use tools to access real-time information or suggest a real-world action. So if you think about it, think about like leveraging a database retrieval tool to access specific information like customer purchase history, so it can generate tailored shopping recommendations. It can make various API calls to send an email response to a college or complete a financial transaction on your behalf. To do so, the model must not only have access to a set of external tools, it needs the ability to plan and execute any task in self-directed fashion. So this combination of reasoning, logic, access to external information that all connected to a generative AI model invoke the concept of an agent. So essentially a program that extends beyond the standalone capabilities of a generative AI model. This could remind something we heard before, RPA. Agents are not RPA. They're not robotic process automation. RPA is a piece of technology that mimics humans' actions on UIs. So clicking of buttons, copying of data. It's a layer on top of the UI. It's very fragile, inflexible, unable to handle exceptions or learn. It breaks if UI changes. So if a button moves or a form changes, and that can derail a whole entire workflow. In the last, I would say 5, 6, 7 years, have been haphazardly deployed into enterprise with huge promises made by consultants for 30 to 50% cost savings overnight, no IT overhaul needed. These systems require constant maintenance, and essentially it's artificial intelligence. It's kind of like a mechanical Turk, so an automation that is pulled by human from the side. So I just wanted to remind everybody and differentiate for that, because we've been hearing sometimes RPA coming up in conversations. And what we're seeing in Wahid described as well is this move from chat-based systems that emerged a couple of years ago, where humans take actions, to agents where humans direct and oversee that action. And we all familiar with generalist chat. So Gemini, ChatGPT, Claude, they provide general knowledge. They require hands-on human to operate them. And we're moving to an AI agent. So an agent that executes tasks autonomously with human oversight. And then further into multi-agent systems, a network of autonomous agents. And then beyond that, we see the agentic enterprise, so a fully autonomous business unit or organization. The opportunity we see is to replace work itself. So you can think about replacing a single job or potentially replacing a whole workflow of jobs. So in a single job, and a good example would be Devin, a startup that is working on creating a fully autonomous software engineer. A whole workflow of jobs could be a startup that is trying to create a autonomous law firm, or you can think about a business unit or a function within the business that has a workflow of jobs. Previously, we've seen software in enterprise targeting about 230 billion as an opportunity. So today, the value of a SaaS industry, so your services, your work days, all of these tools that complement our work, it's a sizable market of about 230 billion. It was a huge boom in the last decade. We really see the death of SaaS coming. So SaaS is essentially a UI layer that sits on top of a database, a crude database, a database that can create, read, update, and delete records. So if you think about a salesperson, what a salesperson has today, in many cases, is a tool that he uses alongside their job. They can enter data. So for example, contact data of a prospect they meet. SaaS manipulates that data, so it can calculate when was the last time you spoke to a contact, and then it displays the data, so you can see when was the last call that you made to a contact. So it's quite useful, but we're moving somewhere completely different. So with traditional B2B SaaS, we're augmenting human work and services with software. Now, the software itself is going to do the whole job. So, for example, 11x are working on creating a fully autonomous business development manager that can take care of a whole stack of jobs. And it's a very different approach at solving the work itself and not just augmenting work. So from Salesforce CRM used by a salesperson, we're moving to a sales agent. From there is an app for that to there is an agent for that. And the opportunities here is enormous. Knowledge work is about a $5 trillion opportunity for cost reduction, efficiency, and new value being generated. So where is this opportunity? We think the opportunity is where the unit economics are 100% better than hiring or subcontracting the job. This is the areas you should look for to tackle. And to achieve these 100x unit economics, you need two things to exist together. You should target cost-cutting capabilities, so essentially automating repetitive work, but also you should look for added value at the same time, so driving greater revenues via enhanced personalization. And the desire to flexibly scale up and down labor like a server with a click of a button. This is something that businesses globally and the UK are looking into because of the kind of economic environment that we're in. So here's a quote for the FT saying that 50% of UK business leaders said they plan to redirect investment from staff to AI as a result of an increase in employees' national insurance contributions announced in the October budget. Klarna last year was very vocal about utilizing AI. So Sebastian Simiatowski said in August that AI could help the Swedish buy now, pay later group reduce its number of staff by about a half. The company's headcount fell more than a fifth to 3,500 last year. They famously retired Salesforce and Workday from their estate, their IT estate. So where is likely to find an opportunity for an agent? You should look for simple, repetitive, high-volume tasks. Maybe it's areas you try to automate with RPA and failed. It's not possible to fix the problem by throwing more bodies, as the resourcing is difficult. Onboarding and training is relatively long for a simple task. If you think about a business development manager doing outbound calls on LinkedIn and LinkedIn and email is fairly simple, but onboarding a context of a company is not. Many steps fragmented across different tools, so you can unify that. High fault tolerance, so the risk for error is low. You're not entrusting human lives in an agent. And hyper personalization increases value. Increase in speed guarantees ROI, and around the clock workforce is possible. These are kind of key signs for something that is ripe for an agent implementation. So another pattern we're seeing and kind of gathering momentum in the last few weeks is this idea around the rise of a reasoning machine. We're all familiar with the transformer technology in one way, in one level or another in terms of technicality, but I think most people understand this idea of a token that is predicted step by step, and the transformer suggests the next token, the next word, and that's kind of how the magic happens. So what we've seen recently is the rise of the reasoner. So a model that uses chain of thought prompting. Essentially, it breaks down the problem to steps in the same way as a human does. It's based on this idea that researchers noted that if you tell a large language model to take a deep breath and think step by step as a prompt, you get much better results. So here, I really like this meme that I saw on Twitter, where when O1 first reasoning model was released by OpenAI, that it's actually just a model kind of thinking through the steps that it makes. But the difference is huge. It really drastically improved results across a huge group of tasks. Google, OpenAI, xAI, Claude all recently released deep reasoning models. They reduce hallucinations significantly. They're quite expensive due to the compute cost. And the combination of an agent and a reasoning model really unlocks new frontier of capability when you think about how to automate certain tasks. I want to mention DeepSeek because it is a reasoning model, and it's really changed things again. You can say a lot of things about DeepSeek, and there are suggestions that potentially the model distilled GPT. Maybe the cost to train it was not as low as suggested because it's a Chinese company and you can't trust their data. What is very clear is that approach they used was unique, and it's very, very cost effective. So you will see this model now appearing everywhere. And my main point is that it's available open source on Hugging Face for the world to use. So it's been downloaded 4 million times so far. And this reasoning capability is going to enter the agentic space as well. So what are the high-level first steps to introduce an agent? What you really need to think about is creating a visual representation of the process in a unit of work. You need to lay into research to understand jobs to be done of a user, of a current job, how it's actually being done, and being able to break it down and understand it as a process and visualize it. Then you need to select the right unit to be automated. And we've shown which opportunities are ripe for automation. And also we showed kind of the architectural high-level steps of creating an agent. You need to understand system of storage and APIs to be able to make the agent actionable. And then you design that agent to satisfy the jobs to be done. You really need to think from the start of how this job can be done. That's where the opportunity is, radically rethinking it and redesigning the entire process. Another trend that is just around the horizon is robotics. So when we talk about automating the unautomatable, there's another barrier that is about to be broken, and that's actual physical work. So here you can see a Figure 2 robot that's been unveiled in August, and recently we've seen a bunch of videos emerging. This is on the way as well, so automating physical AI. And we think that every company should focus on building an AI agent infrastructure because you can unlock these new labor pools. and you should be thinking how you will change as an organization to manage AI workers. Or maybe you should think about how humans will be managed by AI. Kind of jokes aside, we really don't think humans are going away. If anything, expert human judgments become more crucial, and work will evolve from doing to orchestrating and validating the work of AI systems. That's it. That's all we have for you today. Thank you so much for joining. I had a lot of fun delivering this. Thank you for your time.
Cool. Well, thank you both very much. That was very interesting. We have a few questions in the comments. Some you might have answered by the time we got to the end, but let's just make sure we cover them anyway. In a B2B context, what are the practical considerations for building enterprise-grade AI agents?
I can jump on this one. One of the main topics that come up a lot when giving agents autonomy within the enterprise B2B environment is authorization, authentication, how they can embed into an already UMS system within the organization where all the documents and knowledge base have been classified for different groups of people, and there's like an access control on that. How much authority should agent have? How do we distinguish between what information one agent can have access to and how much the other? So you can see a lot of companies that focus on the security aspect and authentication authorization aspect have jumping on this subject and try to rethink how they not only serve users but also serve agents at the same time. So I think security is one of the top things in the B2B environment.
I think in general, everything we talked about so far is in B2B and enterprise context. Our company works mostly in B2B and enterprise, and we think about those opportunities. So this is less about kind of the consumer implications and more about how you redesign, rethink, and rebuild some of enterprise processes to be agentic.
Thanks. And here's one as well about, hello, thanks for your presentation so far. In a multi-agent system, can we assume an agent who controls and manages other agents? I think that might be for Heed again.
Yes, 100%. This is actually a best practice for that. We mentioned that with LLMs, a back and forth conversation always works the best. And while sometimes you take that role as a user, working with a model and give it feedback to get the response you want, same that can happen with an agent. So we've had concepts already, such as LLM as a judge, which means that one LLM judges the output of other LLM. Facebook published a paper 2 months ago, I think, with the concept of agent as a judge, where this work can be more proactive. So just give you a bit of example, the way that LLM as a judge works is that it looks at the output of the first LLM and just label it with, I'm happy with this, I'm not happy with this, and that's it. But in an agent as a judge, not only labels that, but actually goes back to the agent and says, no, do it again. This is my feedback. Do it again, consider my feedback, and come back to me again. So this is a best practice already implemented in multi-agent systems.
And for Leon, someone has asked, what did you mean by a mechanical Turk?
So Mechanical Turk is a piece of automation. It's actually a historical example of a self-playing automatron chess player that was given to a Ottoman Sultan that he was very impressed with, but later was found out that there was a little person sitting inside the table and manipulating the chessboard with leverages. And it's a concept in kind of previous iterations of AI. So before large language models, transformer models, or even neural networks emerged, a lot of AI was essentially people labeling at scale or doing tasks at scale. So Amazon has a Amazon Turk, where you can via API outsource tasks at scale. So a lot of the image labeling was done like that historically. If you think about Facebook and its censorship programs, it was hundreds of thousands of people labeling images because national NLP and image recognition could never handle it properly. Today, that's completely changed with large language models and transformer models and neural networks.
Thanks. And how many agents are we talking about here, guys? How many agents will the organization have? Tens, hundreds, or thousands?
The way that I look, well, first of all, it depends on the workflow that you're trying to automate. The way I see it is that you have a vertical complexity where you allocate your roles and personas and you break down the tasks towards many different agents, depending on the complexity of the task and how long the workflow is, because some of them have more steps. You may have more agents involved. So the way that I think about it is that many of workflows can be done with maybe 10 to 12 agents, depending on the use case. But then you have the horizontal scaling, that you want to put these agents to work on 24/7. So I can see that that would work in a horizontal scale. Then you multiply these systems to work in parallel, and that would increase the agents to maybe hundreds. There are obviously some limitation and caps. Compute always is a cost, so that always keeps that horizontal scaling low, and the extent, like the amount of API that these agents use as well, because they're machine, they frequently use the APIs much more speed and much more frequently. That also can be a limitation that would enforce to keeping the agents slow and not scale them too much horizontally.
And you mentioned that AI agents are good for when the risk of error is low. How do you quantify and evaluate risk in an organization? Like, human in the loop versus full autonomy. How do you actually qualify that?
It's usually already defined in most organizations around with compliance and risk and cybersecurity. So the riskier areas already will be kind of outlined. You can just follow organizational structures to be able to, to see those, and just choosing the ones that are not the ones that are the easiest path through, the easiest and less resistance path through, are the ones that I would suggest to choose. I would not jump on anywhere where compliance is going to be on top of your
100%. Just to add to what Leon said as well, you can see that the most of the risk relies in the organization core business and all the workflows that are in the main business objective of the enterprise. But you have all the things around it that carry a lower risk. For example, there is always accounting, there is always PR, there is marketing, there is customer support, and there is sales. And all this ecosystem around a business carry a lower risk, usually face lower level of regulations, and can be low-hanging fruits for introducing multi-agent systems.
Cool. And how far is this away? Are lots of companies doing this? Where are we on the adoption curve?
It's already have begun. I think it has started early 2024. I'll show you the stats on how many systems are in production in terms of the peak that we had since 2023. Depends on how cutting edge the organization is. Software engineering sometimes is built in the culture of some organizations, and they usually lead the way that they experiment with these works. I was chatting to one of my friends who developed an orchestration framework for agents, and he was telling me that how much ahead companies are in Silicon Valley compared to London. So they are already have a stuff in production. Is all about maturing, and they're in the next iteration of learning from what they did in production and have the second round with much better systems. adaptation is a bit on an earlier level within Europe. I go to the events and I see a lot of startups that the whole business model is around having agents and automating jobs that used to be done by human.
And the final question, guys, what organizational changes do you think are necessary for enterprises to effectively manage and oversee a workforce that includes AI agents?
So what I think, so I'm having a software engineering point of view, and I'm sure Leon would have a more strategic point of view on that as well. The way I see it is, first of all, talent and a skill set. So an organization have to think whether they want to invest and have a AI dedicated team to work on the systems. That needs a new view towards software engineering. This is a new paradigm. So whether they have to bring in people that know this paradigm already, or invest in upskilling the existing engineering talent that they have. And then there is some impact on the workflow that they want to automate. So clearly, that means that they're going to be able to optimize their human resource in those workflows in other places, because they're going to need less. And the human resources available on those workflows and remain, they will be upgrade to a more oversight responsibilities rather than actually doing the job themselves.
Yeah, I think that's a really key, because one of our principles in implementing AI is this idea of human in the loop. So where in the processes the human is in the loop. I think that's a key change that needs to be made and thought through when you redesign the process. And like we said, you find the areas where there's units of work that you can apply an agent to satisfy jobs to be done. Where in that process, in the workflow, you have the human in the loop. I think that's an important change.
Great. Well, if anyone wants to learn more, the white paper is available on the website. If you have any questions, please do get in touch. But thank you both again to our speakers, and thank you everyone for joining. Have a lovely morning.
Thank you very much.
Thank you.
Bye-bye.
Thank you.